Assalamu alaikum. My name is Ashmal Adim from BS Physics, Lahore College for Women University. Today, I am here to welcome you all for our 4th International Conference on Emerging Trend in Physics to see where the future of the science is shaped today. The work, day, or life cannot be started without Allah subhanahu wa ta'ala name, who is the creator of the universe. So I would invite Mr. Abdul Wahab, BA student from Lahore University for recitation of the Holy Quran.
أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. لا يستوي أصحاب النار وأصحاب الجنة أصحاب الجنة هم الفائزون. لو أنزلنا هذا القرآن على جبل لرأيته خاشعا متصدعا من خشية الله. وتلك الأمثال نضربها للناس لعلهم يتفكرون. هو الله الذي لا إله إلا هو عالم الغيب والشهادة هو الرحمن الرحيم. هو الله الذي لا إله إلا هو الملك القدوس السلام المؤمن المهيمن العزيز الجبار المتكبر سبحان الله عما يشركون. هو الله الخالق البارع المصور له الأسماء الحسنى يسبح له ما في السماوات والأرض وهو العزيز الحكيم. The resident of the fire cannot be equal to the resident of paradise. The resident of the paradise will be successful. Had we sent down the Quran upon a mountain, you would have certainly seen it humbled and torn apart in a way of Allah. We set forth such comparison for people they may reflect. He is Allah, there is no God except Him, the King, the Most Holy, the All-Perfect, the Source of Serenity, the Watcher of all, the All-Might, the Supreme in might, the Majestic glorified is Allah for above what they associate with Him. He is Allah, the Creator, the Inventor, the Shaper, He alone has the most beautiful names. Whatever is in the heaven and in the earth constantly glorifies Him, and He is the All-Might, All-Wise. Sadaqallahu al-Azim.
Jazakallah khair. Now keeping the name of Muhammad sallallahu alaihi wasallam just next to Allah subhanahu wa ta'ala, I would like to invite Malaika Arif, BS student from 7th semester, Lahore College for Women University, to brighten our hearts with Naate Rasul Maqbool.
जलवाए जाना जलवाए जाना मौलाया सल्ली व सल्लिम दाइमन अबदन अला हबीबिका खैरिल खल्क़ि कुल्लिहिम मौलाया सल्ली व सल्लिम दाइमन अबदन अला हबीबिका खैरिल खल्क़ि कुल्लिहिम ना कोई आप सा होगा ना कोई आप जैसा था कोई यूसुफ से पूछे मुस्तफ़ा का हुस्न कैसा था ज़मीनो आसमां में कोई भी मिसाल ना मिली मौलाया सल्ली व सल्लिम दाइमन अबदन अला हबीबिका खैरिल खल्क़ि कुल्लिहिम दलीले ज़िंदगी वो है कमाले बंदगी वो है कोई भी दौर हो उसमें मेरा जे आदमी वो है वही तो दीन दुनिया है जो बातें आपने कही मौलाया सल्ली व सल्लिम दाइमन अबदन अला हबीबिका खैरिल खल्क़ि कुल्लिहिम
Jazakallah khair. Today, we feel honored to have with us Honorable Chief Guest, Professor Dr. Manzoor Ikram, Director General of NILOP Islamabad, Professor Dr. Akhtar Hussain Sandhu, Principal of Government Graduate Islamia College, Civil Lines, Lahore, Dr. Pavel Kowalczyk from University of Poland, Dr. Rafia Faruqi, retired Senior Faculty Member of Physics Department, Professor Dr. Rehana Zia, ex-Chairperson of Physics Department, Professor Dr. Safia Anjum, Head of Department of Physics. I would like to invite them on the stage and take their places. Thank you so much. Now I would request all of you to stand for national anthem. Acha. Dr. Zohra, you also have to come, the co-chairperson of Physics Department. Please, ma'am, come on the stage. Thank you, everyone. I would now start with the welcome note address session. It will be my pleasure to invite Dr. Safiya Anjum, Head of Department of Physics, on the stage, a great personality who has been serving as profound researcher and as chairperson of Physics Department.
Bismillahirrahmanirrahim. Respected worthy Vice Chancellor, she is busy in her tour to Islamabad. So with the permission of Vice Chancellor, Professor Dr. Uzma Qureshi, the Chief Guest, Dr. Manzoor Ikram, Director General of NILOP, Guest of Honors, distinguished guests, all deans, directors, chairperson, faculty members, and my dear students, Assalamu alaikum. It is with great pleasure and profound honor that we welcome you to the 4th International Conference on Emerging Trend in Physics. This is a joint venture of Faculty of Science and Technology with the Department of Physics, ComSet Lahore. We are delighted to host this gathering of thought leaders, experts, and visionaries from the globe. This conference serves as a beacon for the advancing knowledge, fostering partnership, and addressing the challenges of current era. With a diverse lineup of speakers, keynote speakers, invited speakers, interactive sessions, and dynamic discussions, we will be confident that this conference will help the researcher to get new ideas. Your presence enriches this event, and we deeply appreciate the time, energy, and expertise you bring to this forum. Together, we have an incredible opportunity to learn from one another, celebrate our shared successes, and pave the way for a bright and more collaborated future. I also want to inform the information about the Central Research Lab at LCWU, which is working under the leadership of Mr. Farooq Bashir. This lab is equipped with high-tech equipment like a scanning electron microscope, XRD, UV visible, FTIR, LCR meter, electron beam deposition, photo simulator, and many others. And in this conference, we get opportunity to sign a MOU between NILOP, National Institute of Laser and Optronics, with Department of Physics, LCWU. Dear all, your active participation and contribution will make this conference unique and fruitful for the researchers. Once again, we extend our warmest welcome and wish you a memorable experience in this conference. Thank you very much.
Thank you so much, ma'am, for your kind words. Now, I would like to invite Professor Dr. Manzoor Ikram, the Director General of the NILOP, National Institute of Lasers and Optronics in Islamabad, Pakistan. He earned his PhD in quantum optics from Quaid-e-Azam University in 2001 and holds MSc in nuclear engineering from the same institution. As a professor of physics, Dr. Manzoor Ikram has made significant contributions to the fields of quantum optics and quantum information science, with numerous publications and citations to his name. Under his leadership, NILOP, National Institute of Lasers and Electronics, has advanced research in areas such as nanomedicine, agriculture, biophotonics, and quantum optics, fostering collaborations with academic institutions.
Chairperson, Safia, distinguished guests from abroad, and our new generations, we hope that you will come up to foster science more. I welcome you all, and first of all, Assalamu alaikum to all. It is my great pleasure to come here and to address inaugural speech in front of girls here. It is very nice opportunity, and I congratulate Dr. Safia to have this fourth international school on emerging technologies. This emerging technologies is very encouraging, very essential for yourself to encourage your research, because you do here research in basic sciences. This basic sciences should have your research in applications. I'm here representing an industry. NELOP is a kind of industry, a research institutes. Research and R&D institute, it produces equipments for the military and for the agriculture, for the medical sciences. So your research, whatever you do research, it should be applicable to the human. Later I will give a talk on the equipment, on the technology NELOP is doing there. At NELOP we have laser facilities there. We produce lasers and we do laser applications. We also have quantum technologies here. These days, quantum technology is one of the high-tech area. At NELOP, we are doing research in quantum technologies. We are developing devices for the military and for the industry. And similarly, we have a very nice laboratory of plasma. We have Plasma Tokamak Institute there. So I think here at LCWU, there are several students doing research in plasma, in lasers, in semiconductors. In semiconductors, NELOP has, I think in Pakistan, there is only one facility that can grow semiconductor devices. So at NELOP, we have the facility of growing semiconductors, their characterizations, and their packaging techniques. At NELOP, we have these facilities. So today, we will have a signing ceremony of NELOP with LCWU. We will welcome the students from LCWU University to come there for research in the field of semiconductor, in the field of lasers, and in the field of quantum optics. And with these remarks, I thank the organizers again. Thank you very much.
Thank you so much, sir, for your valuable words. Now, I would like to invite Professor Dr. Atikur Rahman, Chairman of City and Regional Planning. Now I would like to invite Professor Dr. Akhtar Hussain Sandhu, who is a distinguished academician and researcher. He has made significant contributions to his field and has published numerous papers in prestigious journals. Dr. Akhtar Hussain Sandhu is highly respected by dedication to education. He has supervised numerous students and collaborated with international scholars on various projects. As a renowned professor, Dr. Akhtar Hussain Sandhu continues to inspire and mentor future generation of scholars. So please, sir, come on the stage.
Bismillahirrahmanirrahim. Thank you very much for the honor that you invited me to this very prestigious conference. Although I am a student of history, but even then the physics department has honored me to invite. Thank you very much. Actually, we always listen, especially I'm talking to the students, we always listen about knowledge economy. And what is knowledge? There is difference between education and knowledge. Education is just to collect a certificate or a degree from an institution by a examination. But knowledge is referred to research and how we get expertise in research. As a student, we need to get expertise in two fields: subject tools and then language proficiency. These two things are very important. And how we educate our students in the institutions by assigning them some topic before midterm or after midterm examination. Assignment writing is very important. That has become futile exercise in the universities. I don't know about the physics or science students, but I'm talking about the students of social sciences, कि उनकी जो language proficiency है वो बहुत ज़्यादा weak होती है. आपको पता है कि if you are earning something online, definitely you must be expert in the language. If you have language barrier, so you will not be able to present yourself or your research at international level. तो असाइनमेंट राइटिंग एक ऐसा टूल है जो असातिज़ा आपको हर सेमेस्टर में एक टॉपिक्स वगैरह देते हैं और स्टूडेंट्स सोशल साइंसेज के लिहाज से वो बिल्कुल उसको हम छापा कहते हैं. कायदे-ए-आज़म यूनिवर्सिटी में जब हम पढ़ते थे तो उसको छापा हम कहते थे कि वहाँ से जो प्लेजराइज्ड मटेरियल है वो हम उसको वहाँ पे उठाते थे और किसी जगह पे उसको रख देते थे. तो छापा इज़ नो मोर रिक्वायर्ड बाय आवर यूथ. If you want to be successful in life, then you will have to learn the meanings of knowledge. Knowledge is research. और research की जो आपकी training होती है, वो यही है कि assignment writing में आप बहुत ज़्यादा serious हों. और मेरा नहीं ख्याल कि इस वक्त कोई भी ऐसी यूनिवर्सिटी हो जिसमें assignment किसी student की library में रखी जाए as model. तो we do expect from our students कि आप अपनी सब्जेक्ट टूल्स आपके पास है, लैंग्वेज प्रोफिशिएंसी लेके उसमें मेहनत करें और आपकी असाइनमेंट्स शुड बी केप्ट इन लाइब्रेरी. तब यू विल बी ऑन द राइट ट्रैक. मुझे मैं जब 3-4 साल से एज अ प्रिंसिपल ऑफ इस्लामिक कॉलेज सिविल लाइन्स काम कर रहा हूँ, मेरे लिए बड़ी परेशानी की बात होती है जब पेरेंट्स हमारे पास आते हैं कि बच्चे के नंबर लगवा दें ये प्रैक्टिकल के. और ऑल आर साइंस स्टूडेंट्स, ज़्यादातर जो है वो 90% हमारे पास स्टूडेंट्स गवर्नमेंट कॉलेज लाहौर से आते हैं, सिविल लाइन कॉलेज में. तो एज अ स्टूडेंट ऑफ सोशल साइंस उसके ऊपर मैं गौर करता हूँ कि ये जो हमारी क्रीम ऑफ स्टूडेंट है और उनका ये हाल है कि वो अपने नंबर लगवाने के लिए हमारे पास आते हैं. हाउ दे विल compete at international level as a science student. कैसे वो साइंस में स्कॉलर बनेंगे, कैसे आगे निकलेंगे हमारे स्टूडेंट. सो इन द स्टार्ट ऑफ लास्ट ईयर आई वाज इन कनाडा. तो वहाँ पे भी मैंने यही इसको बल्कि मैंने उनको ये भी कहा कि एक बहुत बड़ा मेरे ख्याल के मुताबिक एक बिजनेस है जो लाहौर में अगर कोई उसकी फंडिंग कर सके, कि लाहौर के करीब एक बहुत बड़ी लैब होनी चाहिए. क्योंकि हम यही कंप्लेंट रिसीव करते हैं कि जी वहाँ पे लैब होती नहीं है, लैब वर्क करवाते नहीं हैं टीचर्स. तो एक लैब जो है वो कायम की जाए जिसमें स्टूडेंट्स के लिए महीना या 2 महीने के लिए वहाँ पे उनको एक्सेस दी जाए, और जितना भी इक्विपमेंट है, इंस्ट्रूमेंट्स हैं और केमिकल्स हैं, वो उनको बेहतरीन तरीके से दी जाएं ताकि हमारे साइंसदान हम प्रोड्यूस कर सकें. हम शायर, अफसाना निगार, ये तो सारे अपने फील्ड में काम कर रहे हैं, मीडिया मैन, लेकिन साइंसदान हम कितने प्रोड्यूस कर रहे हैं? ये इस चीज़ के ऊपर ये क्वेश्चन मैं आपके लिए छोड़े जा रहा हूँ. एंड आई होप कि ये इस तरह के जो इवेंट्स हैं वो एक झंझोड़ने वाली बात होती है कि जो स्कॉलर्स, prestigious scholars come from different universities and they present their research work and expertise. तो ये एक्चुअली स्टूडेंट्स के लिए एक वो एक एहसास होता है कि स्टूडेंट्स उन मॉडल्स को देखें कि हम इस लेवल के कैसे जा सकते हैं और कौन सी डायरेक्शन अडॉप्ट करें. सो आई कांग्रेचुलेट वाइस चांसलर ऑफ दिस यूनिवर्सिटी, डॉक्टर सफिया, chairperson of physics department, faculty, and the students of this department that they have arranged a wonderful event, and I hope that that would be productive and useful for the students and teachers. Thank you very much.
Thank you so much, sir, for your valuable words. Now I would like to introduce Professor Dr. Pavel Kowalczyk, a distinguished academic figure known for his contributions to higher education in Poland. He has served in leadership roles at several prominent universities in Poland, where his expertise in research and teaching has been highly valued. Dr. Pavel is particularly known for his work in the fields of science and technology, where he has made significant strides in advancing academic knowledge. His work has earned him numerous accolades and recognition both nationally and internationally. Dr. Pavel remains an influential figure in shaping the academic landscape of Polish universities.
No, is it not? Red not working? Yeah. I will provide you the green for the height.
Just in case. Okay, welcome. Good morning. My name is Paweł Kowalczyk. It is a great pleasure for me to be here and to be able to deliver my talk to you. I thought what to talk about, and I decided, I'm constantly changing the way in which I'm telling about the science. Maybe it will be too basic for you, so I'm sorry about that, but this is something which is just a beauty. The beauty of the science. So I came from Poland. Poland is located in the center of the Europe. As you see, the weather in Poland is rather cold, I would say. So right now we are suffering due to lots of snow in the country. So average, mid-average is minus couple of degrees right now. And during the summer we have 18 and 19 degrees in the shadow. The city by itself is very nice, very old city, very industrial one. The university is one of the largest universities in Poland. We have 12 faculties, 80 field of studies, 40,000 students, as you can see on this slide. The science which I'm in is surface science. So we are interested in surfaces, and surfaces requires the clean environment. So we are mainly using vacuum systems for our science. And we used to live in classical world. We are looking at classical phenomena, but actually at the bottom it is completely different, as you know. So in quantum world, the boy is not playing soccer anymore because the ball can tunnel through the wall, and car can tunnel through the hill and appear on the other side. So this is the principle. I mean, quantum world is the principle of a technique which is called scanning tunneling microscopy, which I grew up from. Basically, you have a tip which scans over the surface, and this type of microscope is able to see atoms. If you think about world, okay, and you have Earth and the beautiful atmosphere which allows us to live. The radius of the Earth is around 6,000 kilometers. The diameter of the atmosphere is around 100 kilometers. If you compare this to the desk, which is slightly lower than the ones which we are using, 63 centimeters, so the atmosphere is a book on the desk, roughly 1 centimeter thick. If you take the mountains, very small one, not as high as you have here in Pakistan, so 1,000 meter high mountain. This corresponds to 1 page, roughly 0.1 millimeter. If you take the building of typical size of 15 meters, this corresponds to the bacteria which is on the desk. The smallest bacteria known to humankind are Mycoplasma, with the sizes of below 2 micrometers, so they are really the small ones. If you take the size of typical human, 1.8 meters tall, you have to use computer to give a proper comparison in our world located on the desk. So the gate size in computer in 2000 was around 180 nanometers. So if you take this size in comparison to the desk, to the world, and now you're looking at the desk, you are finishing with two-dimensional materials which you can hold in hands. So this gives a comparison how small these materials are, and where to search for them, of course, in periodic table of elements. So the very first, the most famous, the father of fathers is graphene, of course. So we have quite a long experience with graphene in our group. First paper published just a year after the Nobel Prize, so 2005. And actually there is an accent related to Pakistan, related with this paper, because there was a PhD student from St. Petersburg, Zafar Vakwar, who came to us in 1998, so 7 years before the paper was published. And he brought graphene. So investigated the graphene, got the results, but we couldn't publish it because there is something which is called Landau curse. So when we sent the paper to the journal, there was a very short reply from reviewers. It is well known, Landau showed that years ago, that two-dimensional materials does not exist. Period. That's it. And the paper was rejected. It turns out that what allows two-dimensional materials to exist are wrinkles. Okay, so the flat two-dimensional materials do not exist, but if they are slightly buckled, then they are stable. So the other two materials which were discovered are silicene, germanin, stannine, borophin, and there is a huge group in 15 group of periodic tables based on pycnogen atoms. I like them very much because there is a number of crystallographic phases. So there is alpha phase, beta phase, gamma phase, delta phase, eta phase, zeta phase, and so on. So there is huge diversity of two-dimensional materials in this group. And another one is related with chalcogen atoms together with transition metals. They create transition metal dichalcogenides. very interesting group. Because you're also dealing with diversity of materials, diversity of structures, which is quite cool for science, because each of these materials have different properties. But to investigate them, I mean, from my perspective, from surface science perspective, to investigate these materials, we need clean environment. So a couple of words about Raman and our recent development. So we bought a simple spectrometer, that's it, nothing more. And we started developing, so version model 1.5, January 2019 is a simple microscope with this spectrometer, which is connected. We put it into the glow box, actually. So that was the highest development, but it was very inconvenient for PhD students the PhD students who have been building this device, because whole day he has been spending having hands inside of the glove box, so it is very uncomfortable working like that. So he thought, oh well, I have to change that, and our other construction is the microscope which has motors integrated together with the all light path, and it is right now integrated into glow box. So in total, we have a fully operating system which allows us to do some nice experiments. So the proof of concept. So for proof of concept of this construction, we selected rhenium oxide. Why? Because even short exposure, below 1 second exposure to air, causes that it hydrogenates very quickly, changing into either rhenium trioxide or HRE04. So we have our crystal inside of glow box, and you can see the Raman spectra of it. And we are measuring this Raman spectra after a month, 20 days. It is different, okay? There are differences, but it is quite similar. So we, repeating the experiment, we're having, again, a clean crystal, then exposing it for, in total, 15 seconds, because we had to take it out, keep in air, load it again. So the morphology changed a lot, as you see on the right side. But the Raman spectra changed as well a lot. So it is very important to keep the materials clean, because environment could change them a lot. So the next step in our research and development, let's say, in terms of equipment, is merging Raman with STM in order to get something which is called TERS, Tip Enhanced Raman Spectroscopy. So we have it working right now, but I cannot show you any results because there is none results at this stage. So why rhenium oxide is important? Because it is a very important material, it might be very important material for photovoltaics or light-emitting diodes. Why? Especially if you combine it with graphene. So we have this flexible substrate, graphene on top, and you have to use either molybdenum oxide or rhenium oxide to change the work function of graphene. Typically, work function of graphene is at the level of 4.2, 4.5 electronvolts, and to have the working device, you need to have it at the level of 5 electronvolts. So in our research, we focused only on these two layers. We evaporated rhenium oxide. It wasn't a simple experiment because it evaporates very slowly. But what you can see is that we have been able to push the work function from the level of 4.2 up to nearly 5. And this actually allowed us to build light-emitting diodes, organic light-emitting diode, which worked. So the question which we asked ourselves, because the previous experiment was on a very thick material, we had around 5-7 nanometers of amorphous layer. So we're changing right now to molybdenum oxide and asking ourselves question, could we be better? And so we will try to, we tried to grow monolayer molybdenum oxide, and we succeed. You see a few STM images of monolayer molybdenum oxide. And it turned out that it can push the work function even higher, above 6 electron volts. So in this sense, the question if amorphous layer, 5 nanometers thick amorphous layer is better or crystalline layer is better, the answer is yes, crystalline layer is far much better, because it is ultra thin, below 1 nanometer, absolutely transparent, and potentially flexible. So we are collaborating with our colleagues from Warsaw University, with Wojtek Pacuski, who delivers us very nice samples, and how we protect them against oxidation. So they are covering it with capping layer, with metallic capping layer to protect them from air. We can exfoliate, then expose the clean material inside of glow box to work on it. This is confirmed by XPS, so basically if the material is exposed to air, it oxidizes relatively quickly. In terms of the quality, it's not so good still, because there are lots of holes in this molybdenum ditelluride. But we measured Raman spectra, and that was surprising that there is no strong feature. So we used to think that two-dimensional material, or Raman and two-dimensional material, is a very good marriage. But apparently for molybdenum ditelluride it is not. So we decided to go for thicker films, and that was one of the, from my point of view, quite interesting discoveries. So you are dealing with optical image on the left and atomic force microscopy on the right. And when we measured, when we used technique which is called Kelvin probe microscopy, Kelvin probe microscopy is measuring the quantity which is proportional to the work function. You see the different colors. So what these colors mean? It means that the work function is changing from place to place along this material. But when we compare this result, this was the old sample, year old. When we compared that with the fresh one, it turned out that the change of the color, which you see here versus the region here, was different. So the fresh one was different, the old one is different as well. So the explanation, so the obvious question is why? So explanation came with DFT calculations. So for basically for clean material, the change of the work function as a function of thickness is not much. But for oxidized samples, you have relatively huge changes of the work function. So as I told you, when we did Raman measurements on the variety of thickness, mainly the dominating factor is background. So it is very difficult to see the signal of molybdenum ditelluride. So we decided to do control experiments just to understand what's going on, why. So we went for typical interference substrate, which is silicon and silicon oxide. We did a number of experiments. So this is molybdenum ditelluride. And what we discovered is that if you change the thickness is expressed here in nanometers, you have first slow increase of the intensity of the peak. There is a maximum and decrease. So we did the same experiment on molybdenum disulfide. It is even more interesting because first you have growth of intensity, then decrease, then growth again, then again decrease. So we did again molybdenum MOS2 on gold just to check how it behaves. The statistics was much lower, but we had growth, decrease, and the growth started to appear. We went for tungsten ditelluride, quite similar behavior, and oxide. So we're getting back to oxide. For oxide, it's completely different. Okay, so you see that there is growth, but the maximum, the decrease start to show when the films are at the level of 140 nanometers. Or so what's the explanation? The explanation is the effect called Fabry-Poirot resonance. So you have the laser, the light, which enters between the two mirrors, and it starts to reflect and amplifies itself or not. So the physics is relatively simple behind. If you look at the amplitudes, you have the amplitude which hits one side of the mirror, it goes inside with some transmittance. It is either reflected here with reflection, or it goes outside, having another multiplier with which is transmittance through the mirror. And having this in mind, it allows us to understand why the oxides, what the materials, scene materials are so colorful. So this is the example of molybdenum oxide, molybdenum 3 oxide. You see a number of colors, and we can calculate the change of the color as a function of thickness, and this gives a very good match. So for me, the most important material on which I'm working is bismuth. This is the lion for me of all two-dimensional materials. I know that for you, lion might be graphene, but we are different people, so bismuth is my one. Bismuth is last non-radioactive material in periodic table. It has two structures, either hexagonal or rectangular, and we differentiate these two by adding letter alpha or beta. The origin of the name is Weisse Masse from German, and it was officially discovered in mid-18th century. Why it is important for physics? Because it has quite strange properties, I would say, and these strange properties led to a number of discoveries in physics. So magnetoresistance, the Haas-von Alpen effect, Shubnikov-de Haas effect, and so on and so on. So we are evaporating this material on substrate, and you are seeing the younger version of the guy who is standing at the stage right now. And please enjoy the journey toward into the sample. So at the very bottom, we have, of course, atoms on all these kind of samples. We are growing them in a number of different structures. Love hearts, that's for all ladies here, so the structures could be sometimes very strange. What's the explanation for these kind of shapes? Of course, grain boundaries, which we understand relatively well right now. So this material is semiconductor, but when we did ARPES measurements on this material, we discovered that there is no band gap in experimental results, and we wanted to understand that. So what can we do? Go for better equipment. We did some experiments in electrosynchrotron Trieste to understand better this material. This allowed us to measure the single crystal, the single crystallite, and the very first discovery was coming from, so this result is from LEM, low energy electron microscopy. There is maybe hundreds these kind of microscopes across the globe. For experimental physicists, it is state of the art. You can do everything with this equipment, especially if it is connected to synchrotron. And we used LEAD, one of the modes of LEM. So LEAD stands for low energy electron diffraction. And the very first thing was that we seen lack of one of the spots. It was very weak. So this missing spot has a huge importance for physics, because when you are looking at from side on the crystal, you see that it is puckered, or it's supposed to be puckered, but this missing spot means that it is not a correct model. The crystal is actually flat. And if the crystal is flat, this introduces additional symmetry. So if you look at these these zigzags here, you have additional symmetry, which is called non-symmorphic symmetry. And non-symmorphicity is quite interesting. You can understand it when you are looking at footprints on sand. So how can I generate the image, the reflection image of left feet versus the right one? So first I have to do the mirror reflection, and then I have to shift. Then I get the left side can be transferred to the right one. And this actually introduces, if the material has rectangular symmetry, this introduces some conditions will lead to formation of Dirac cones in all high symmetry points in electronic structure. So in very last few slides of my presentation, I would like to tell you about another experiment which was complete surprise for us. So we started to grow the material, and LEM allows you to see the growth. So you have a bare substrate here, and when we start to grow material, you see that the structures start to form. But if you look closer to this to the symmetry, you will see that this is not a static image. The islands are shaking; they are jumping back and forth. So this was complete surprise for us, because this means that this system is not stable. There is going something in the background there. So the fact that the islands are hopping and they are hopping along straight lines led us to the conclusion that we are dealing with something which is called superlubricity. So there is complete disappearance of friction in these systems along a particular direction, and when we draw the histogram of jump length, we discovered that if it is plotted in log-log plot, it is a straight line. What does it mean? It means that most probably we are dealing with something which is called Levy flights, and Levy flights or power laws. Levy flights are very important because animals search food in such a way. So the animal, the bird, for example, is searching in one place. If there is no food, it makes a small jump somewhere further away, searching over there, from time to time making jump further away. This, I think, means that I should go toward the end of my talk, so maybe I will jump through last slides, and we'll go directly to the conclusion. So my conclusion is that there is, I can only repeat after the Nobel Prize winner, there is plenty of room at the bottom. So physics is very diverse. We are looking up, we are looking down. I mean, I'm from DISC, who are looking at the nano scale. And I think that Richard Feynman was right, that there is a lot of room at the bottom, and all of us could do nice science in this scale. Thank you for your attention.
Thank you so much, sir, for such an informative session. Now I would like to invite Professor Dr. Faiza Salim, Director of ORIC, LC College, Lahore College for Women, University, Lahore, on the stage. Now it's time for the bigger announcement of conference, which is memorandum between Lahore College for Women University and NILOP, National Institute of Laser and Optronics. Physics Department, Lahore College for Women University is going to sign the memorandum between National NILOP, National Institute of Laser and Optronics. It will help the students of Lahore College for Women University to have premier research as NILOP, National Institute of Laser and Optronics, had advanced research facilities. It also enables researchers to conduct high-precision experiments in fields like material processing, optics, laser, and nanotechnology. It also helps the students to have skilled workforce in laser, optronics, and advanced technologies. And of course, international collaboration. Let's have a huge round of applause. Everyone, please have a huge round of applause. Now I would request our Now I would request to all our honorable chief guests to come in front of the stage and to collect their shields. Now I would request all of our honorable chief guests to come in front of the stage to collect their shields. Wait a sec. I would request to Chairperson of Physics Department to give shield to Chief Guest Professor Dr. Manzoor Ikram, Director General of NALOP, National Institute of Laser and Optronics. Then to guest of honor, Professor Dr. Akhtar Hussain Sindhu. Now to the distinguished guest, Professor Dr. Rehana Zia. Now to the distinguished guest, Dr. Rafika Faruqi. Professor Dr. Rafika Faruqi. And now to the keynote speaker, Dr. Pavel Kowalczyk. Now, ladies and gentlemen, let us now to Professor Dr. Shahid Rafiq, Dean of University of Engineering and Technology, Lahore. Now, ladies and gentlemen, let us have a tea break. The respected guest will have tea break at committee room, and in meantime, the poster session will also be conducted, and we will assemble together at sharp 12.